transferred across to something else that is reduced. Oxidation is the loss and reduction is the gain of electrons from redox reactions you obtain. Half reactions can be written out as well and combine to produce a galvanic cell. Oxidation is the loss and reduction is the gain of electrons from redox reactions you obtain. Oxidation happens at the anode and you'll find reduction happens at the cathode on the other side.
So today we're talking about chemistry balancing of redox reactions. A redox reaction can be balanced in two mediums, the acidic medium and the basic medium. Today we'll be talking about the acidic medium. What is an acidic medium? An acidic medium is a medium having a high concentration of hydrogen ions. And to balance a redox reaction in an acidic medium, we do that by following these steps. Splitting the redox reaction into oxidation and reduction half equations. Yes, because a redox reaction is a reaction that involves an oxidation reaction and reduction reaction occurring concurrently, or what we know as simultaneously. So the next thing to do after we have splitted our redox reaction into oxidation and reduction half equation is to balance the atoms, and this is done effectively by adding hydrogen ion and water molecule appropriately. The next thing is balance the number of charges using electrons, balance the electrons, and eliminate excess specie and add up the equations. The steps are very easy to follow. Not to worry, by the time we take a sample question, you will see how easygoing the steps can be. Our sample question is this. Let's see how to go about this. First of all, we have to identify which of these specie in the reactant side is being reduced and which has been oxidized. By the time we identify this, we'll be able to know which of those equations will be split into our oxidation half equation and which will be our reduction half equation. There will be a video to identify oxidation and reduction half equation, but for now we are just doing the balancing of redox reaction. So our solutions, step one, we have to split our equations into oxidation half equation. Now, because this is iron 2 ion and this is iron 3 ion, iron has lost electron to become iron 3, and that is why it is passed to be called the specie that has been oxidized, giving us the oxidation half equation. It has been oxidized from being +2 to +3. Oxidation can mean so many things. By the time I do a video on what oxidation really means and reduction, you will see that oxidation is a loss of electron and also it is an increase of oxidation number. So we just have that. So we also have a reduction half equation. You don't need to worry your head about which of this is going to be oxidation half reaction and which of this is going to be reduction half equation. No. Once you are able to identify one specie as being oxidized or being reduced, definitely the other specie has done otherwise. So the other specie will be otherwise. That is, if you have identified an oxidized specie, the other specie is reduced, definitely. So we have splitted our equations into oxidation half equation and reduction half equation. The next thing to do is to balance our atoms, like our steps has given to us earlier. We have the second step here is to balance our atoms. Looking at the atom we have here, iron. ion is 1 on the left hand side, and it's also 1 on the right hand side. So we can say that ion atoms are already balanced. So we are going to balance the atoms in the reduction half equation. This is where we need to introduce our hydrogen ion and water molecule appropriately. Now, looking at this equation, you see that there is manganese here in our manganese oxide ion, and there is also manganese on the right hand side, but then we do not have oxygen on the right hand side, so we have to introduce oxygen there. To introduce oxygen on the right hand side, we will have to add our water molecule to the right hand side. And then by the time we do that, we have also introduced hydrogen on the right hand side. Definitely we will also have to introduce hydrogen on the left hand side, and that is by adding our hydrogen ion. I hope you understand that. So we'll just erase that and we'll see our equation. So we have this. So by the time we do this, we'll have our manganate. This is actually called tetraoxomanganate 7 ion, and we have gotten this, introducing our hydrogen ion and water molecule appropriately. So the next thing to do now is to balance the atoms proper. To balance our atoms, we'll have to do an atom count on the left hand side and on the right hand side and balance appropriately. So we have manganese on the left hand side to be 1, and on the right hand side to be also 1. We have oxygen here on the left hand side to be 4, but here it is 1. So we have to introduce what? 4. We introduce 4 to water molecule. By the time we have done that, we have invariably turned our oxygen atom on the right hand side, which is 2, to 8, because 4 times 2 is 8, and therefore we are going to add to the right hand side 8. So that gives us our balanced equation atom wise. We get that. So that is what brought us to this equation, manganese in that form. So that equation is balanced atom wise. We now have manganese. We now have our manganese to be 1. Manganese here 1. We have our oxygen here 4. We have our oxygen here 4. We have our hydrogen here 8 and our hydrogen here 8. 4 times 2 to be 8. So we have balanced that equation atom wise. Atom wise, that equation has been balanced. So we move to the next thing. So we move to the next. The next we have our step 3. We are now going to look at the charges. We want to balance the charges now. Now looking at this, we have ion 2 and ion 3. Ion 2 has the charge +2 and ion 3 has the charge +3. Remember that we said earlier that when balancing our charges, we are going to introduce electrons. So we have to balance our charges adding electrons, E-. Adding electrons. Now, to what side are we going to add our electrons? This should not worry us. The first thing you have to do is to identify the difference in the charges of the left hand side and from that of the right hand side. Looking at this, on the left hand side we have +2 and on the right hand side we have +3. So this is not balanced. One is greater than the other. So we are now looking for which of those side, the left hand side or right hand side, are we going to add electrons to balance that charges. Remember, our electrons are negatively charged. Therefore, we are going to be adding electrons to the side that has the greater charge. To the side that has the greater charge. So between the left hand side and the right hand side, which side has the greater charge? I guess you should know that it is the right hand side. It has a greater charge, which is +3. So by the time we add a negative electron to it, then we are going to be adding 1 minus, that is 1 electron to that side to be able to give us what we want. So we'll have that. So we have added 1 electron to the right hand side because the right hand side carries the higher charge. So that gives us equation 1. So we'll go to balance the charge of our reduction half equation. Now looking at these, the reduction half equation, we have to be very careful because we have introduced some certain species and also balance them atom-wise. So let's see. For our manganese oxide, we have it to be minus, manganese oxide is -1, and our hydrogen ion, which is supposed to be +1, is now +8 because we introduced to it 8, and then our manganese ion is +2 on the right hand side, and we have water molecule. A molecule actually has no charge, so that is 0. So by the time you look at the total number of charge on the right hand and the left hand side, it will give you +7. -1 + 8 is +7, and on the right hand side we have +2 and 0. So the total number of charges there is +2. So we are good to go. We now know the total number of charge on the left hand side and on the right hand side. So that is very much easy to now tackle. So we have that. So like I said earlier, we can easily identify that the difference between the charges on the left hand side and the right hand side is 5 by mere looking at it. But you can also use algebraic equations in your head on a rough sheet to get the difference. And that is what we have by doing this. +7 plus x equals to +2. And by the time you do collect like terms, we get our difference to be -5. So there's a difference of 5. A difference of what? 5. Remember I said that to balance our charges, we'll be adding electrons now, and we are definitely going to add electrons to the side that has the greater charge. So looking at our two sides, the left hand side and the right hand side of our reduction half equation, we will see that the left hand side has +7 as a total number of charges, and the right hand side has +2 as a total number of charges. So here we have it that the left hand side has the greater number of charges. So to it, we are going to add our 5 electrons. Our difference of charges is 5. So we are adding 5 electrons to the left hand side. So we get this. So having written this, we name that equation 2. We name that equation 2. So that's what we have. So now we are now going to balance the electrons in our next step. So in our next step, we bring down our equation 1 and 2. To balance these charges, we are going to multiply each of these equations with a factor of the electron in the other equation. What do I mean? Because we have 1 electron in equation 1, we are going to multiply equation 2 by 1 electron. And because we have 5 electrons in equation 2, we are going to multiply equation 1 by 5 electrons, so that the number of electrons in equation 1 will be equal to the number of electrons in equation 2, so that we can cancel out electron and balance electrons like we have said earlier to be our step 4. So that is what we have. So by the time we multiply equation 1 by the factor 5, we will have that to be 5. We'll have 5 iron 2 ion, 5 iron 3 ion, and definitely 5 electrons. So for equation for the next equation we do not need to balance, we don't need to write anything again, because we are multiplying by factor 1, so it will still give us the same thing. So we just brought down that equation 2 again. So that is what we have. Now we are now going to go to the next step, which is adding up the equations and eliminating the electrons necessary. So we have it to be this. So by the time you see this, we have added up all the specie on the left hand side in one place, and all the specie, I hope you can see that, we have brought down all the specie on the right hand side here, and then we brought down all the specie on the left hand side here. Hope you can see that. So that is what we did. And the next thing we will now do, because we now have equal number of electrons on the left hand side and on the right hand side, we'll cancel out electrons. Electrons will be cancelled out. Cancel out electrons, cancel out the electrons. By the time we do that, we'll now write down the remaining specie we have in that equation. We'll write it down and we'll have that. So we'll see, we now have this as our equation, and our equation is balanced. But can we verify if our equation is balanced? Let's go. We are going to verify by doing an atom count and doing also a charge count. So let's do that. So looking at the charges, the charge of our ion here, ion 2 is let me change the ink here. Ion 2 is going to give us that ion 2. So we have ion 2. Ion 2, because we have added the factor 5, it's now 5 times 2, which is plus 10. And then for our manganese oxide, we have minus 1. For our hydrogen ion, we have plus 8. All of these charges now sum up to give us a plus 17. And then we go to the right hand side. Let's see if it corresponds to our plus 17 we got on the left hand side. So we have here ion 3. We have added also a factor 5 to ion 3, giving us what? Plus 15. And then we have our plus 2 for our manganese ion. And for our water molecule, which has no charge, which is 0. So by the time we also sum up our plus 15, plus 2, plus 0, we'll have plus 17. So we see that our charges on the left hand side is equal to the charges on the right hand side. So we can also verify all of our if our atoms are balanced. And also verify if our atoms are balanced. Let's see that. Okay, let's see that our atoms are balanced. You see here we have 5 ion on the left hand side, and we also have 5 ion on the right hand side. And then we have manganese 1 manganese here. We also have 1 manganese on the right hand side. And then we have oxygen to be 4 of them there. On the left hand side we have 4 oxygen. Sorry, I mean to write oxygen. So we have that. Oxygen is 4 of them, 4 oxygen on the left hand side, and also 4 oxygen on the right hand side. And then we have our hydrogen on the left hand side to be 8, And then we also have our hydrogen on the left hand side to be what? 8, because 4 times 2 is 8. So we can see that we have balanced our redox reaction both atom wise and charge wise. Okay, so that is the end of today's class. I hope you enjoyed it. Please, if there's any question you want to ask about what has been taught today, you can leave a comment in the comment section below. And please, if you are new to my channel, do well to subscribe, like, and share. And remind you, I have a particular audience I am targeted to meet, and these are secondary school students who find it difficult to understand chemistry. So please and please, you can please share this my channel to those my targeted audience. You have them as your younger ones, you have them as your neighbors, your auntie kids, and the rest of them. Just anyone you know who needs to understand chemistry. Please share to them, ask them to subscribe, like. Thank you and God bless you. I'll be waiting for your reply. I'll leave on the section below my WhatsApp number. You can call me and ask any question. Then I'll send you a voice note for further explanations. Thank you.